Okay. So I'm going to video this and post it, but I think that the test that you guys are taking is 50 minutes. So it is, I think when do we get out of here? Is it 20 after or 40 after? 40 after. Okay. So we got lots of time. We've got over half an hour we could review, but I don't care how you guys want to do it. Here's kind of what I was thinking. I'd review a little bit with you guys on the test, take questions and stuff like that, give you the test, which you may not even need 50 minutes. I don't know. But if you need all 50 minutes, you can take all 50 minutes. And then I was going to practice some of the stuff for the homework for this week. Okay, that was kind of my goal for the day. But if we need to use more time for review, we can. All right. So I'm going to go and just start kind of reviewing some of the big ideas, and then we'll go over the practice test. And let me get my clicker. So here are the big ideas from chapter 1. So as I go through this, you'll probably think, yeah, I kind of remember that. So we have 3 undefined terms, right? And guess what they are? Point. And by the way, how do we label a point? With a dot. That's how we draw it. And then we use an uppercase letter for naming it. Okay? Hey, you've been running late most every day. Is there a reason or?
Well, somebody picks me up.
And they're running late? Okay, fair enough. I didn't mark you absent today because I figured you'd come in. Anyways, so we have a point. Now, it seems kind of contradictory that it has no definition. The reason it doesn't have a definition is because you end up using what's called circular reasoning and defining a point by basically saying a point. Does anybody know what another one is? Well, besides a point, there is this thing called a line. And a line is kind of this thing here, right? It extends in both directions infinitely. We could label it with 2 dots or 2 points, and those are, again, uppercase letters. Or we can use a script letter like L, Lionel Richie. And does anyone remember what the third undefined term is? Yeah, plane. So a plane is represented by a flat surface that extends without end and has no thickness. We typically need to use 3 non-collinear points to name it, or sometimes you'll see us use an uppercase script letter. Okay? Any questions on points, lines, or planes? And those are just things like on the test. I'll just say name the point of intersection or name the line going through these 2 points or something like that. Okay, so then we have this thing called a segment. Now, a segment actually is a defined term. We can define what it is. A segment is part of a line that contains 2 endpoints and all the points between them. So this is a segment AB. Now, remember, when we name a segment, the notation we use here is a little bit different. If you remember, for a line, we have the little arrows. Here, we just use the segment symbol itself. So that's segment AB. And it has a length. Another term that we have here, defined term, is array. Array has an endpoint and then all the points that extend in one direction. So it's like part of a line. Okay, so guys, here's where I'm going to have to pause. I just heard someone come on here. Okay, so I was talking about an array, and when we use array, it's the line segment and then it has an arrow going in one direction. And what does this point here have to be? What does this end point here have to be? That A has to be that end point of the ray. Okay, so remember what I'm saying is ray AB is different than ray BA, right? Because they have different endpoints. Does that make sense? Any questions on segments or rays? Okay, so there were some postulates in this chapter, or this section. There's 4 of them. Through any 2 points, guess what there is? Exactly 1 line. That's what this postulate says. It says through any 2 points AB, there's exactly 1 line. Through any 2 lines, guess what you have? Exactly 1 point. In other words, if these 2 lines intersect, their intersection is exactly 1 point. It can't be 2 points or 5 points or something like that. Through any 2 distinct planes, guess what their intersection is? It's a line. So this plane and this plane intersect at line ST. And then the 4th postulate is this. through any three non-collinear points, there's exactly one plane. So that kind of goes back to what we've said already. So that wraps up section 1.2. So section 1.2 is kind of easy. It's more about notation and naming conventions. Does that make sense? Okay, section 1.3, measuring segments. This is actually a very short segment, or section. So the ruler postulate just basically says that you can assign a value or a length or coordinates to a segment. So if I had this segment here, segment AB, I can ascribe some length to it, some real number. Like in this case, I could say it's, 3 inches or whatever. This is the big idea. This is the one that when we went over in class, I said, this is the important one. I put a big star on it. And it's segment addition postulate, which basically says this. If this is 2 and this is 5, who can tell me what the whole thing is? It's 7. Now, I know that that's super simple. Remember, a lot of times on the practice problems, I'll give you something like x plus 2 and 2x minus 7. I'm making stuff up. And then I'll tell you this whole thing here is 50 or something like that. And then you got to figure out what x is. Okay? And so you would just say this plus this equals that. Any questions on section 1.3? That's it for section 1.3. It's short. Okay, measuring angles. So first of all, you got to know what an angle is. This is an angle. What's the name of this angle? It's angle 1. And you could literally write angle 1. Or what's another name for that angle? Angle BAC. Now, you have to make sure that that A is in the middle because that's the vertex point, the common point. Protractor postulate. Protractor postulate, all it does is it says for every angle, you can assign a measure to it. So you could say that angle is 125 degrees. An acute angle is an angle that's measured as less than 90. A right angle measures exactly 90, and we use that little box there to represent 90 degrees. Obtuse is bigger than 90 and less than 180, and then a straight angle is exactly 180 degrees in measure. So those are based on that protractor postulate. There's one more thing missing in this section. Does anybody want to take a guess on what it is? I'll give you a hint. It's something very similar to what we just saw on the last slide. On the last slide, we had something called segment addition postulate. It's called angle addition postulate. And here's what angle addition postulate says. If this measure of this angle is 20 degrees and the measure of this angle is 50 degrees, what would be the measure of angle AOC? 70 degrees. 70 degrees. Okay, section 1.5. There are 4 things defined. One are adjacent angles. So angles 1 and 2 are adjacent. That means that they have a common vertex and a common side, but no common interior points. In other words, they can't overlap. That's what we call adjacent angles. Vertical angles, like angles 1 and 2. Angles 1 and 2 are vertical angles because they are 2 angles whose sides are formed by opposite rays. And then we have complementary and supplementary angles. Complementary add up to 90 degrees. So the measure of angle 1 plus the measure of angle 2 is 90. Supplementary means they add up to 180. 180. Oh, I think I might have left one thing off of here. Do you guys remember what a linear pair is? Let me draw you a picture. Guess what we call angles 5 and 6? We call them a linear pair because they are adjacent and they form what kind of angle? What kind of angle is this right here? It's a straight angle. So guess what's true about linear pair? They are always supplementary. In other words, they always add up to 180. Okay, and then the very last section, midpoints and distance. So if I want to find the midpoint of this segment right here, and I know that this is at 2, and let's say this is at 8, what would be M? How would we find the midpoint? Well, you take the 2 and the 8 and you add them and then divide by 2. So what would that give you? 5. So the coordinates of the midpoint are 5. We can extend that into the two-dimensional coordinate plane like this, where there's an x-axis and a y-axis, and we do the same thing. We just do the average of the x-coordinates. That'll give us the x-coordinate midpoint, and we can average the two y-coordinates. So it's really just an extension of what we just saw. And then the last big idea from this chapter, and I guess there's one other thing I should probably mention, we'll talk about it here in just a second, is the distance formula. This formula was first introduced to you in Algebra 1. In fact, you used it in Algebra 1. And you just kind of need to memorize it. It's x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So let me give you a quick example of that. Let's say that one point A is at 0 and B is at 3, 4. Okay? So first thing I would recommend that you do is actually, what's this? This is x1, correct? What's the second 0? It's y1. What's this x? That's x2. What's that one? y2. Now we're going to just take all that information and we're going to plug that into our formula. So the distance is going to be the square root of, okay, so I got to put x2, so that's 3, minus x1, oh, that's 0, plus y2, let's see here, y2 of 4, minus y1, that's 0, squared. So that's going to be the square root of 3 squared plus 4 squared. That's going to be 9 plus 16. And what is the square root of 25? It's 5. Of course, I picked an easy one there, right? Worked out nicely. Didn't have to use a calculator or anything like that. That's chapter 1. Did that seem that crazy hard? Or did that seem reasonable? A lot of the stuff you probably already knew, to be honest with you, right? A lot of this stuff is stuff that you would have learned in pre-algebra in middle school. Now, last thing I want to mention here. Does anybody recall what that symbol means? Or what do we call that? What is that symbol? Say again?
An equal sign.
It's not an equal sign. An equal sign is this. This is an equal sign with this on the top. Does anybody know what we call that symbol? It's called congruent. And for example, we could say that angle 1 is congruent to angle 2. And that's just another way of saying that the measure of angle 1 is equal to the measure of angle 2. Congruence is just that whatever characteristic that you use for the angle is the same. In other words, their measures are the same. What if I said that segment AD is congruent to segment BC? What does that tell you about B? So let's say I've got, let me draw a picture. So let's say that this is A, there's A, here's B, and here's C. What has to be true about B? If segment AB is congruent to segment BC, what has to be true about B? That's exactly right. This has to be the midpoint. Because if these two guys are congruent, that's basically saying that this segment's congruent to that segment. And if those two segments are congruent, their measures are the same, and therefore it's a midpoint. Okay? All right, so that's it for that. That took me, way too long.